All right, ladies and gentlemen, we are looking at 5.1 mid-segment theorem. Okay. A mid-segment of a triangle is a segment that connects the midpoints of two sides of the triangle. So let's make a picture. I'm just going to do one mid-segment. There are 3 for every triangle, but let's do one so it's real clear. Okay, so let's draw a triangle. Okay. The mid-segment is midpoints. So if we take the midpoint of this triangle, I know that these two sides are equal to each other, right? Because the midpoint's in the middle. If I take the midpoint of this side of the triangle, I know these two sides are congruent, right? Because midpoint means right in the middle. All right? The mid-segment, that's what we're looking for, is these two midpoints connected. That's the mid-segment. Questions about mid-segment? Makes sense? Midpoints connected to each other? Okay. The segments connecting the midpoints of two sides of a triangle is parallel to the third side and is half as long. Okay. Let's draw another picture to try to explain that. We've got a triangle. Again, we've talked about we've got our mid-segments. They're connected. These two sides right here are parallel. What do we know about parallel? Parallel means they have the same what? What does parallel mean? Slope. Same slope. So I might write a little thing to myself. Parallel means same slope. Okay. And it says that it's half as long to that other side. So that means that if this side right here is 8, what's my mid-segment? 4. Right. Okay? That's just an example. The mid-segment is not always 4. Okay? Don't write that down. We know it's half as big. Okay? What if I knew my mid-segment was 2? What would the third side of the triangle be? 4. It'd be twice as long. If my mid-segment was 2, the third side would be 4. So if your inside's 2, yeah, that was rough. Okay. Let's go ahead and try some of these problems. All right, remember these pictures are going to disappear because the computer's funky. I will put it back up if you need it later. Okay. We're going to do a lot with graphing points and making coordinates. So let's make sure we've got this. Okay. First, we're going to draw a triangle that has these vertices. A is negative 3, 0. 1, 2, 3, 0. I like to write not just the letter A right here, but I like to write what it is. I know this is negative 3, 0. Okay. Next, we've got B, which is 3, 6. 1, 2, 3, 1, 2, 3, 4, 5, 6. And we've got C, which is 7, 2. Negative 2, excuse me. 1, 2, 3, 4, 5, 6, 7, 1, 2. So right here, this is my triangle. All right. We are going to use the midpoint formula to find the coordinates of D, which is the midpoint of AC. Okay? And E, the midpoint of AB. Anybody remember the midpoint formula? So it's x1 plus x2 divided by 2, comma y1 plus y2 divided by 2. You guys tend to mix this up with the distance formula. So you might want to put this on your postulate and theorem sheet. Label this midpoint formula. Okay. Sometimes even if you already have it on there from chapter 1, circling it. Okay. All right. So I'm going to look at points. I want to find the midpoint of A to C first. A is negative 3, 0. and C is 7, negative 2. At least for the first couple of these, I recommend that you label them. Okay? It helps me. X1, Y1, X2, Y2. So we've got X1 and X2. So negative 3 plus 7 divided by 2, and 0 plus negative 2 divided by 2. Negative 3 plus 7 is 4. 4 divided by 2 is 2. 0 plus negative 2 is negative 2. Negative 2 divided by 2 is negative 1. Did I do that too fast? Why won't you draw? Silly computer. All right. Anyways, 2, negative 1 is D. So I'm going to go over 1, 2, down 1. That's D. Okay, now we have to do another one. Instead of A and C, I'm going to look at A and B. So A is negative 3, 0, X1, Y1. And B is 3, 6. Oh, dear. Put it right here. Okay, so I'm going to have X1, negative 3, plus 3 divided by 2. X1, X2, comma, Y1, 0, and 6 over 2. Negative 3 plus 3 is 0 divided by 2 is 0. 0 plus 6 is 6. 6 divided by 2 is 3. And this is letter E. So let's plot that on there. Miss Murphy, speak. Yes. Yes. He is. Do you want me to send him to you? Okay, no problem. Yep. Darnell, Miss Holden wants to see you, so write yourself a pass and sign out and then go see Miss Holden. Okay. All right, so E is 0, 1, 2, 3. Okay. All right. Now, we have to show, so the midpoint's not too bad, right? We're okay with the midpoint formula? We've done this before. We did it in chapter 1. I know it feels like a long time ago, but we did. Now we have to prove that E to D, this line right here, is parallel to BC and is half as long. So you have to do two things. We have to use the distance formula. I know your favorite thing in the world. And we have to find the slope. I think the slope's easier, so I'd like to do that first. We okay with that? Okay. So our slope is between B and C. So we've got, this is B. Ooh. So we've got B, which is 3 and 6, and C, which is 7 and negative 2. So we're going to find the slope there. And then we're going to find the slope for E to D, which is 0, 3. So this is E to D. Okay. So finding the slope first. Who remembers what the slope formula is? Anybody? Yep. Y2 minus Y1 over X2 minus X1. All right. This is our second formula. So we need to make sure we have these formulas down and labeled correctly. When it asks you to find if it's parallel, you're going to use the slope formula. So that might be something to write down on your paper too. Let's label it X1, Y1, X2, Y2. Negative 2 minus 6 over 7 minus 3. Negative 2 minus 6 is a negative 8. So if I put X2, Y2, and X1, Y1, that would be fine. Negative 2 minus 6 is negative 8. 7 minus 3 is 4. 4 goes into 8 how many times?
What, oh.
Twice. Anybody have a question? Yes. Okay, so that's the slope of BC. So ED better be the same slope, right? Or else this isn't working. Okay, so this is x1, y1, x2, y2. So y2, negative 1, minus y1, which is 3, over x2 minus x1. Negative 1 minus 3 is negative 4. 2 minus 0 is 2. 2 goes into negative 4, negative 2 times. Same slopes. That means they're parallel. Good. Now, I have to say, I don't really like the distance formula either. It's really long. I strongly recommend you learn how to stick it in your calculator. Okay? So, Keyshawn, I'm confused what you're doing. Oh, I didn't know. Okay. All right. So, remember, ladies and gentlemen, this is being recorded and this is taking a little bit of time. So, let's move on. Okay. Let's find the distance. Anybody remember what the distance formula is? It's the square root, yep. So again, we're looking at, let's do it. Okay. We're doing the square root of y2 minus y1 squared plus x2 minus x1 squared.
So
yes?
If like it comes out and there aren't the same slopes,
Then we know that they cannot be a midsegment.
so
You wouldn't have to do this part.
No,
Since we know they're parallel, what do they have to be? The lengths have to be, the midsegment has to be half the size of that. So we're going to find BC.
Will they all work or will some not work?
I don't know. Okay. Are you guys writing this down? Yes? You're following me? You're asking questions? Okay, let's plug it in. So we're going to plug in this first one. So we've got y2 is negative 2 minus y1, which is 6 squared, plus x2, which is 7, minus x1, which is 3 squared. So you pull out your handy-dandy calculator. You put in the square root sign, then you put parentheses. Negative 2 minus 6 squared plus parentheses 7 minus 3 squared, and then put one more in parentheses. And I get approximately 8.94. Okay? Let's look at this next one. Yes?
Why did you have to do the 8.9?
Why did I have to find this number at all? This is how to find the length. And we have to prove that the midsegment, ED, is half as big as BC. So now I know the distance between A and B. B and C, excuse me. And now I have to find the distance between E and D. So I'm going to do the same thing again, the distance formula. Good questions. Y2 minus y1 squared plus x2 minus x1 squared. Again, let's just stick this in our calculator since it's a lot of stuff. Negative 1 minus 3 squared plus 2 minus 0 squared and parentheses. And we get approximately 4.47. And if we multiply this by 2, it gives me that. So it is half as long. I know, it feels like it's doing too much, but we're going to do more of these. We're going to look at example 2 now. You guys need a break? You guys need to get up and stretch for a second, or you just want to push through?
I want a break for a second. Can I get up
Okay.
and stretch?
All right. So after our little break, let's look at example 2. We've got, and it's all messed up here, so ignore this. Look at your paper. ED and DF. Oh, this isn't even labeled. It's horrible. A,